Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And of course today I want us to discuss example 2 of Pure Mathematics 2, page 51, and we are continuing to talk about exponentials and logarithms. And in this example we are asked to sketch the graph of y is equals to a half raised to power x minus 3 and give the coordinates of the point where the graph crosses the y-axis. And we start by saying if we have a y which is a function of x and it is primarily a half raised to power x, just fundamentally without considering the minus 3, then we can already see the position of x fx is equals to a half raised to power x. Then it follows that y, which can also be the function of x minus 3, and it follows that when this is the case, then we have a half raised to power x minus 3. You can see the position of x minus 3. It gets to the index position just like we had it here. And we already understand that this one is an addition inside. Already we can see it is a transformation. It is going to be translated. We are going to move the original function or curve, which happens to be this. So if we may wish to sketch y is equals to a half raised to power x and tabulate its information here, we may have the value of x and y. And let me just start with y being x being equals to minus 3. And the reason I've done this is because we already have 3 steps here. So we would want to see how it behaves when we translate it to 3 steps. We are going to see that. So when x is minus 3, y is equals to half raised to power minus 3, which happens to be a half raised to power minus 3. It happens to be 2 raised to power 3, which is an 8, according to the laws of indices. So 8, when x is minus 2, we have y is equals to 4. When x is minus 1, we have y is equals to 2. And when x is 0, anything raised to power 0 is a 1. But when x is raised to power 1, it is half raised to power 1, which remains a half. When x is 2, it is half raised to power 2, which is a quarter. And when x is a 3, a half raised to power 3, which is an eighth. So tabulating this, when x is minus 3, we have y being equals to 8. When x is minus 2, we have y being equals to 4 there. When x is minus 1, we have y is equals to 2. When x is 0, we have y is equals to 1. And when x is 1, we have a half, quarter, eighth. I mean, it continues to decrease, but never it continues. You can see that means when x is minus 3, y is 8. When x is minus 2, y is 4. When x is minus 1, y is 2. When x is 0, y is just 1. And when x is 1, y is a half, quarter, eighth. It continues to decrease, but never touching the x-axis. Of course, this is the graph of y is equals to, this is the graph of y is equals to a half raised to power x, or rather the function of x. Using transformation, we need to revisit the Mayo, and of course you know what Mayo means. This is our way of summarizing the translation and transformation of curves, whereby if you have been following my videos, you would know this means addition, this means multiplication, this means inside, this means outside, this means translation, this means stretch, that means vertical, and this means horizontal. There is a minus a there, 1 over a, and a. And you can't, let's discuss about this. This is basically addition inside. Addition inside the bracket. Addition inside is a horizontal translation of negative a steps. And you can already see that our A is negative 3. So horizontal, there is what you're calling addition inside, which is addition inside, which is a horizontal translation of negative 3 steps. That means addition inside is actually horizontal translation of 3 steps. This means what? Horizontal means along the x-axis and vertical means along the y-axis. That means this means all x values plus 3 steps. So even when we are talking about minus 3 and 8, this point walks that way 3 steps. So this is minus 3, minus 2, minus 1, it will land there. This is 4, this is minus 2, you're going to have minus 1, 0, and 1. This is minus 1x, then we have 0, 1, and 2 there. In other words, the whole graph will shift to the right 3 steps, and you're going to have something that looks like this. You're going to have something that looks like this. Of course, it gets to the right 3 steps, and you can already see this is the point where it cuts the y-axis, and the coordinate is easily 0, 8. And this is the graph of y is equals to, or rather, a half x minus 3, which is fx minus 3, as we have used the Mayo. That is that. We could also extend the same argument this way. If we could also extend the same argument that let me do it in a different page. Alternatively, we can also consider the graph as a stretch of, if y is equals to a half x, which is translating to y is equals to a half x minus 3, we could use the laws of indices here and talks of something like this. This is a half x times a half raised to power minus 3. That is true. And of course, this, when we expect the laws of indices from a raised to power a times a raised to power b, this is a raised to power a plus b. And because this is x minus 3, and because this is x minus 3, then we are talking of if we have a half raised to power x minus 3, I repeat again, this is the same as a half raised to power x times a half raised to power minus 3. And this is what gives us, according to this law of indices, the base is the same, half. This is a raised to power a times a raised to power b is equals to a raised to power a plus minus 3, which is plus b, which our a is of course a half, which is a half raised to power x minus 3. So we can easily use the laws of indices to get to that particular point. Expanding this or dealing with this is the same as a half raised to power x times a half raised to power minus 3 is simply 2 raised to power 3, which is 8 a half x. And if the fx was supposed to be a half x, then 8 a half of x happens to be 8fx. And as you can see, this is again multiplication outside according to Mayo. Let me just bring its Mayo here. Multiplication outside minus a 1 over a. This is teachers should value holiness, and of course this is multiplication outside, which is vertical stretch, multiplication outside, which is vertical stretch of scale factor a, scale factor 8. What does that mean? All y values times 8. And all y values of what kind of a graph? Let us first of all have y is equals to a half x. And we had done it over there. We had done it over here, which looked like this: minus 1, minus 2, minus 3, minus 2, minus 1, and this is 8, this is 8, this is 4, this is 2, this is 1. We have such kind of a graph, and the graph is appearing to look like that. The moment we talk about all y values multiplied by 8, we will talk about another graph which is now translated, or rather let us put it in the same set of axes. 8 times 8 is so much 64 up there. 4 times 8 is 32. 2 times 8 is 16, but 1 times 8 is 8. Of course, a half times 8, you're going to have when x is a 1, when x is a 1, when x is a 2, when x is a 3. When x is a 1, then we are talking about a half. A half times 8 is obviously a 4. That is coming there. A quarter times 8 is a 2, is coming there. And eighth, this one is an 8 times 8 is easily becoming an 1. So the same kind of a graph we saw in the first attempt is going to be repeated here. Of most importance, we can already see that the graph cuts the y-axis at 0, 8. And this is now the graph of y is equals to 8fx. If fx happens to be a half raised. So either way, you will get there, and it is awesome. Please subscribe to my YouTube channel and share widely, and let us work together. All right.